probably know by now, you can answer in the question and answer box. I'll also keep an eye on the chat. So if you have any questions, we'll answer them as we go or at the end. So right to it. So again, this is the annual, we've done this a few years now, and this is actually the first year that I've been one of the presenters, so I'm very honored to be on this. I know that Muriel has in the past, so we typically will do a research update at the end of every year. This is a big year, it's been a big few years for scleral lenses, so we'll try to share with you as much as we can in the short time that we have. I'm going to introduce, probably most of us know the speaker panel. Certainly Stephen and Muriel, but I'll go ahead and give a quick introduction to them. But you'll see a lot of their names on the papers that we're going to talk about today, because both of them are quite prolific with their own research and presentations on that research. And so Dr. Vincent, Dr. Stephen Vincent is at the Queensland University of Technology. So he's in Australia, and he has a very thriving lab that focuses on scleral lens research. And he's got actually 5 PhD students currently. So he's very busy. Again, he's got a huge lab. They do everything from optics to corneal edema to scleral shape. So he'll definitely share a lot of their work with you today. Muriel Schornack is here with us in the United States, and she's up at Mayo Clinic. So Muriel is one of those wonders who sees patients full time and somehow manages to keep herself busy doing research, mostly with scleral lenses as well. So she is one of the main investigators on the SCOPE study, which many of us have heard of, and we'll talk a little bit about today. But without any further ado, I will go ahead. I'm going to introduce Steve Vincent is going to chat first, and I think he just popped up there. And we have some disclosures. We're all part of the Scleral Lens Education Society at first, but of course, but I'll let you take it away, Steve.
Thanks, Maria. And just want to thank the Scleral Lens Education Society for the invitation to present some of the research we've been doing in Australia. So my section today really is to give an update on corneal edema. And in the last few years, there's been a lot of work looking at what factors can we change about how we fit a scleral lens or design a scleral lens to try and improve oxygen flow to the cornea and minimize edema. So we're going to go through some of those studies with you now. So I'd like to acknowledge my co-authors at QUT and colleagues in India who have contributed to this work, and Damien Fisher, one of our postgrads who's been leading this work in Australia, is sponsored by the Cornea and Contact Lens Society of Australia. Okay, so in terms of how can we minimize corneal edema or improve oxygen flow to the cornea in scleral lens wear, I mean, it's effectively the same principle for all contact lenses. We can try and decrease the thickness of the lens material itself. We can try and increase the permeability of the lens material. And then we have this other factor with scleral lenses in that we have a much larger fluid reservoir thickness that we can also play with. Other things that we consider for sclerals are fenestrations or adding a channel to the haptic of the lens. And there really hasn't been a huge amount of well-controlled studies that look at the clinical effect of those modifications. So today we're really going to focus on research that's been done on altering lens thickness, increasing the decay of the lens material, and altering how much clearance you have with the lens. So first of all, look at thickness, and this was some work done by Ken Pullum in the early 90s. So this is a summary of 2 studies here where he had lens material, decay of 115, 2 separate studies, one in 1990, one in 1991, quite small sample sizes, but this was participants with healthy normal corneas. These were impression-based designs, so they were very nicely fitted to the sclera. And what he found was if you had a very thick lens and you gradually reduced the thickness of it, once you got down to about a thickness of about 500 or 600, going any thinner than that didn't really improve how much oxygen got through or how much edema you decreased. So it was a bit of a plateau once you got to about 500 or 600 micron center thickness. which is interesting. So we're sort of getting to a point where, you know, thinning the lens out anymore doesn't make a huge amount of difference. So that was work done in the 90s, and not much has been done since then. So on the next slide we have here, this is some recent work from James Wolfson's team in Aston in the UK, where they've looked at what if we control for how thick the lens is, and we control for the thickness of the fluid reservoir, and we really try and ramp up the permeability of the material. And so in this study, they've looked at so a series of lenses, same lens design, same parameters, same power, same everything, just modifying the DK of the lens. So DK of 65, 100, 125, 160, and 180. And this was a very well-controlled repeated measures study. And effectively what they found was there's a nice drop in edema from DK of 65 to 100, as we might expect. But if we go from 100 up to 180, effectively there's no difference in how much edema you reduce. So this is in young, healthy people. It's not in people with, you know, post-graft or keratoconus, but it's a very well-controlled study, and it very nicely shows that, you know, once you get over 100, you're not getting a lot more benefit there. So from these studies that we've seen so far, we've got Ken Pullum's work, which is showing, you know, once you're sort of over that 100 DK, thinning it out below 500 or 600 doesn't make much improvement. And this study, which shows once you get over the 100 DK, you don't get much more benefit by going higher in terms of edema. So that leaves us with, in terms of scleral lenses, the fluid reservoir, or putting in fenestrations and channels. So, you know, there's been a lot of modeling on how the fluid reservoir affects corneal edema, oxygen delivery in the last sort of 10 years. And all of these models have kind of suggested that, yes, the more clearance you have, the thicker your fluid reservoir, the more edema you're going to induce. But in clinical practice, and I'm sure you've seen this as well, you may fit patients with, you know, a generous amount of edema, a generous amount of clearance with some particular lens designs, and not see a huge amount of clinical signs of edema or corneal stress. So we've been doing some work in our lab, trying to control all the variables and look at what are the true effects of altering the thickness of the fluid reservoir. Okay, so this was a repeated measures study that Damien Fisher's been working on in our laboratories. This is on young, healthy eyes. And in this study, we've tried to control for everything possible. So the exact same lenses, exact same permeability, lens thickness as best we can, and altering the thickness of the fluid reservoir. So we have participants come to our lab, they'll wear the lens for 90 minutes, by which time their edema response is normally plateaued. We see how much edema they have, and then they come back on different days and they have different clearances, and then we see what their response is. And what we found was that on the next slide, you can see on this graph, as the clearance or the initial fluid reservoir increases, we do see an increase in the amount of edema induced, but it starts to plateau once you get to about 500 or 600 microns of clearance. And if you look at this graph, you know, even with a 700 micron average initial clearance, we're still only seeing average edema of around 2% or so. So even with that higher level of clearance in the short term in healthy eyes, you're probably not going to see anything clinically at the slit lamp with just 2% edema. Okay, so that's what we found, and then we thought we'll compare this to some of the theoretical models that have, you know, tried to predict what is the oxygen flow to the cornea, or how much edema are you going to induce if you modify the amount of clearance. So we've got Longy Michaud's study here, where they used a resistance in series approach to try and model how much edema or what the oxygen supply would be through a sealed scleral lens, and some more recent work from Berkeley using sort of how oxygen flow affects corneal metabolism. And they came up with their own model for open eye lenswear. So we extracted the data from those models and compared that to our in laboratory experiment. What we found was for the resistance in series model, it's quite good for the fluid reservoir thicknesses that are relatively low, but it sort of overestimates quite a bit the magnitude of edema that you'll get for higher clearances. Whereas the more recent modeling, which takes into account corneal metabolism, it was pretty good across the board compared to our laboratory-based data. So that was OpenEye lenswear. And this is sort of just a summary of all the studies to date. So we've got Pullum's work in the 90s looking at modifying lens thickness. If we just go back one slide for a second. Yeah, Pullum's work on the left, basically if you decrease your lens thickness, once you're down under 600, you don't get a huge amount of return on investment for reducing edema. Same situation for lens decay, but for altering the fluid reservoir thickness, you can get quite a substantial reduction in the amount of edema. So if you're using a high decay material, which probably everyone in this webinar is for their scleral lens patients, you know, the easiest way to minimize corneal hypoxia is to reduce that fluid reservoir thickness. And we've also repeated this study using closed eye conditions, so exact same experiment that I just described, but after the lens is put in, the patient's lid is taped down, and we modify the thickness of the fluid reservoir or the clearance. And if we go to the next slide, you can see the effect. We basically see a plateau effect as well, so it's not sort of ramping up as rapidly as we might expect from theoretical models. So if we look at the graph on the right-hand side there, you can see the relative increase in corneal edema as a function of fluid reservoir thickness from a theoretical model, which is the green line, and the slope is much more elevated compared to what we see in our laboratory-based measurements. So it's not all doom and gloom with fitting with large clearance. Obviously, you get a lot more. You can get other benefits from fitting with minimal clearance, better lens centration, and you know, better visual performance perhaps. But in terms of oxygen, it's not quite as bad as is predicted from theoretical models. So that's sort of all the work on healthy eyes that's been done in the last few years. And if we just go to the next slide, we'll see another study where we've been looking at the
Stephen, I have a quick question for you before you go on to the next. Do you think that this sort of underestimation of the amount of edema has to do with mixing of the tears perhaps underneath the lens that's going on?
Yeah, so that is a theory that has been put forward. When you start to get these higher levels of clearance, if you get these convection currents happening where the tears are actually starting to mix around, you're getting this circulation of, you know, oxygen-rich tears coming down to the cornea, and the cornea sucking up that oxygen due to the thicker tear layer. So that's yet to be proven, but it is a theory, yeah.
Thank you. I'll let you continue into the disease, guys.
So yeah, all that work we just described was in healthy eyes, and healthy eyes are good for running an experiment, but it's difficult to translate to clinical practice for you guys who are dealing with these sort of eyes, you know, post-graft, keratoconics, eyes that have compromised endothelial function, and you're trying to optimize these patients' vision. And surprisingly, there hasn't really been much work done on how much edema is induced by scleral lenses in these eyes. So if we just go to the next slide, this is a study that we conducted with colleagues in India. So these are post-graft eyes. And this is actually one of the first studies to look at the amount of scleral lens-induced edema in post-graft eyes. So this was a small sample of 10 eyes. On average, patients were 4 years post-graft, but there was quite a range. So this was sort of like a scleral lens challenge. Patients had their corneal thickness measured with pentacam, They then wore the lens for 4 to 8 hours. So this was a 100 DK lens, center thickness of 250 microns. And then after lens removal, pentacam was done again to quantify how much edema we had. And on the next slide, we can see this is what we got. So averaged across the, well, basically you can see from this difference map here, there's sort of a wide range of how much edema happens across the graft, basically. So it's quite patchy and uneven. We found about 3% edema after average 6 hours of lens wear. And there seemed to be more sort of inferiorly closer to the edge of the graft. So on the next slide, we compared this to some studies that we've done in our lab, just on healthy eyes, similar lens decay, similar corneal clearance. And we basically found that, in post-graft eyes, you get about 3 times more edema, which is what we'd expect, but also just heaps more variability in the corneal response. So that was interesting, kind of expected, but really one of the first studies to try and quantify the magnitude of edema in post-graft eyes. And building on this, we hope to do future studies which can also look at what's the effect of manipulating those variables like lens decay, lens thickness, or clearance in these compromised eyes to see how that can benefit you guys in clinical practice. So I think that's all from me. I'd just like to thank the Scleral Lens Education Society and, of course, all the colleagues in the lab who've assisted with this work over the last few years.
Great. Thank you so much for sharing your expertise. So that was great. I know I have a couple questions, but I'll talk about my stuff and then we can chat more about some of your research. So I'm going to take it a little bit in a different direction and talk about some of the studies that we've seen come out specifically this year in regards to tears and so the tear reservoir and the tears on the ocular surface outside of the scleral lens, and also about solutions, because we're seeing more and more studies that actually look at the solutions that we use to clean the lenses or to fill the lenses, right? The saline that we use. So we'll kind of go through that. And I think these are really, really important considerations. Certainly, this is where my research interests primarily lie. So I'll talk a little bit about some of the studies that I've done, but then share what some of my colleagues have done. And actually, you'll see a few of my classmates have actually, from back when I was in school, have been doing some work on this too. But before, this is a lot here. So just kind of focus on the red box. This is just a graph of some of the studies done, or a table of some of the studies done before 2020. The studies I'm going to talk about are all really quite recent, but just to set the stage, there have been a few studies on the composition of the tears itself, right? Postnikoff in 2019 looked at the fluid reservoir. They found some increased neutrophils and other leukocytes in subjects that had midday fogging, so something to keep in mind. We'll talk a little bit more about that again. And then Gonzalo and his friends in Spain found an increase in MMP9 and a decrease in this metabolite here that's associated with dry eye. But all in all, if you look, and then there's a few studies that have looked at the density of the fluid reservoir. To summarize all of these, essentially they're showing that the fluid reservoir is unique. So it's not the same necessarily as the ocular surface tear reservoir, and I'll talk about that in just a moment. But we certainly find that there's something different about the fluid reservoir composition than just the regular basal tears. We don't have a full idea of the full spectrum, right? Because keep in mind, there's 1,500 plus proteins in the tears and that many, if not more, lipids. And so there's a lot to look at, and there's a lot of relationships between proteins and lipids and metabolites that really, it's hard to tell the full story just looking at one or two things, but we're getting there, learning more and more about the individual components. And then the other thing is just that the optical density increases in the fluid reservoir. And that, I think most of us say, yep, that makes sense, even if it's patients that don't have clinically significant fogging. it makes sense that the optical density is going to increase somewhat in there. This is just another table. These are the studies that looked at the tear properties, right? So things like the volume of the tears, the breakup time. A few studies have looked at osmolarity. One even looked at temperature. The take home from this one here is basically that there's no significant changes to the tear properties. And even this one study here by LaFosse in 2018 even did show that the scleral lens actually may help stabilize the tear film for those of our patients who are in the presbyopic population. So good data, if anything, on tears. Doesn't look like we're negatively affecting the ocular surface tears on the surface of the lens anyways. So then what I'm going to talk about here first in 2020 is a study that we had done at the University of Houston, really looking, again, taking it another step in the direction of looking at the different components in the fluid reservoir and looking at a few different cytokines and proteases in the actual fluid reservoir. So there's two types of tears to really distinguish. So if you look at this image here and you look at A, that's when we collect tears from the what we call basal. So you'll see it in this TB as the symbol. And you can see the patient's wearing a scleral lens, but we collect the surface tears from the outside. And so that's one sort of environment of the tears versus the actual fluid reservoir, which is designated as T with a subscript FR. And that's where we actually take the lens out of the eye. You can see here very carefully. And we actually pipette. You can see there's a decent amount of fluid that actually collects in there. So there's those two different separate environments that we can look at. And this is actually the first study that I know of that actually has done that and looked at both the basal tears and the fluid reservoir. And there's still a lot to do, but this is, again, a start. So we had subjects wear lenses for 8 hours and then daily for 4 days to collect 2 samples. And like I mentioned, we looked at inflammatory cytokines. So specifically, we looked at interleukin 4 and interleukin 8. And then we also look at matrix metalloproteinases 7, 9, and 10. Many of us probably are most familiar with MMP9, which is a pretty common inflammatory marker. So if you look at like Inflamadry, that's the commercially available testing kit that will measure, it's sort of a litmus test, but it will measure 40 nanograms per mil of MMP9. Greater than that is indicative of inflammation. So all of these, when increased, can potentially be indicative of inflammation. So what did we actually find? Well, we didn't see any significant increases in interleukin 4 and 8. But it's interesting if you look at it here, because what we have is you've got basal tears here before any lens was introduced. So these were neophyte lens wearers. So collecting from the ocular surface, obviously that's the only place you can collect from when the lens is not on the eye. Then we have them wear the lenses for 8 hours. And we've got the basal here. So this is outside that scleral lens margin and then inside. And each of these dots represents a subject. So this was a pretty low sample size. This was a pilot study. So we had 15 subjects, but ended up getting usable data from about 10 or from 10 of them. So you can definitely appreciate that there's a trend for this number to shoot up here, especially in interleukin 4. But even if you look at interleukin 8 here, the question becomes what does that mean? And I'll share the MMP9 data and then just kind of speak to that for a moment. MMP9 was a little bit different, right? So MMP7, really no relationships at all between the basal tears pre or post scleral lens wear and whether or not we were looking outside the lens or underneath the lens. If you look at MMP9 and MMP10, here we did get some significant differences. And so but at the 8-hour mark, the difference between the inside and outside of the lens is greater. And so really the theme was we saw accumulation of MMP9 and MMP10 in the fluid reservoir. Now, we also saw that trend towards interleukin 4 and 8 also being increased in that fluid reservoir. But that obviously begs the question of, so what? What does that mean physiologically? And we don't really have a great answer for that yet. we need to know more about what the other mediators are that are in the tiers, because they counteract each other, and there also may be increases in things that, like, bacteria or debris, that might actually make an increase in some of these mediators a good thing, because it means that they're working to kind of clean up the tear film because the lens is on the eye. So again, it's not surprising, but I think we do need to figure out exactly, why and when this is increasing, and what the other mediators are that are increasing. But we're seeing more and more data come out, and there's actually another paper that I know is probably impressive, where it's not from my group, that also is kind of starting to look at these sorts of things. So there's more groups looking at it. So we're sort of slowly building the map of what's actually going on. I think the conclusions of the current limited tier composition studies confirm that the fluid reservoir is different, and it is distinct from the ocular surface tiers, with some increased inflammatory mediators. And like I mentioned previously, Postnikov's study back in 2019 showing that there was increased neutrophils, so increased cells in that fluid with patients with midday fogging, at least. But even with the other patients, they had some of those cells in there. But the physiological effect is unknown, and it may actually be helpful, like I mentioned, in sort of maintaining the homeostasis of the eye in the presence of the scleral lens. So I'm going to kind of rapid fire through a few more studies again, just because I want to share some of the really cool stuff that's being done. But I, without going too much into one, so that we get a good overview. So this was a really cool study. Here's one of my classmates. Actually, I graduated with Vivian. So Vivian Say, who's working in Meng Leng's lab up at Berkeley. Again, most of these papers I'm showing are from this OVS special edition, but there's also contact lens and anterior eye, a lot of new papers coming out this year. So there's a couple of them sprinkled in here, but I just stuck to 2020 because there's so much that you could look at. But anyhow, so Vivian's group had this really cool study. So they looked with confocal, and they had normal subjects as well. And they were prospective, double masked, blind, randomized. So they did a really nice job controlling the study. They wore the lenses for 3 months. So they actually got 27 normal subjects to wear them for 3 months. So that's good. They had them use PuriLens and Addipac. So that's kind of interesting, a difference in solutions being used. And what they looked at was dendritic cells. So if you look at this confocal image here at this A, I'm kind of tracing it with my mouse. These are those dendritic cells. They look like dendrite cells with dendrites, right? And then if you look here, these are the nerves. So you can see B is labeling the nerves. So with nerves, there's a paper cited here, but there's a few different papers. I think this was a group in the UK who has written some programs for corneal nerve analysis with confocal, but they looked at nerve fiber density, nerve branch density, nerve fiber length. Again, these are normal subjects, but this stuff is so interesting, because I think and they ended up finding no difference between the two groups, but it would be so interesting to look, like Steve had kind of been talking about, in that diseased population, because there are so many of them in scleral lenses. They also looked at corneal epithelial permeability. So basically put fluorescein in the eye, and this instrument will measure stromal fluorescence. So if you have a higher amount of stromal fluorescence, then after you've instilled fluorescein, then that would imply that the permeability of the cornea is weakened. So really interesting, kind of atypical study that they're doing. That's really, I found very interesting. So, and they found no change. It's like, no news is good news, I suppose. But I think definitely in establishing a protocol to test this sort of thing, I think they really, this is an important paper and methodologies. And they found no change in corneal permeability. And this is just, I'm sharing here, this is their table of how they actually measure. These are the values for, which is the natural log of the fluorescence of the permeability. So again, I think an interesting new area to look at, and will be really, really interesting to see what we see in some of our diseased populations. So a nice job from that lab. And they've ultimately found the results that suggested, again, like 3 months of scleral lens wear had no effect. And Oh yeah, they also looked at PuriLens versus AdiPac, which I found to be really important as well, and found no differences there. So that's reassuring. Here's another cool study with neutrophil. So neutrophil is our new solution out of Contumac that has all these nice nutrients that they've added in to make it a bit more similar to the actual tear film. And so they looked with 22 habitual scleral lens wearers. They were actually looking for midday fogging. So they had patients who reported midday fogging. They used the solution for about a week and a half, almost 2 weeks. They looked at biomicroscopy and OCT to measure the midday fogging. And they also looked at a lot of subjective symptoms. So this was a prospective study that was looking at basically the safety and efficacy, but also whether or not this neutrophil was effective at reducing midday fogging in these patients with keratoconus. They didn't find any change in midday fogging, and you know that doesn't really surprise me. It's kind of a bummer, but they didn't really find any change. But what they did show was that there was a significant improvement in subjective symptoms. So I'm not sure what the masking here was. I don't think they were fully masked, so that we may have to take that with some perspective there. But I think it's very promising, and it shows that this solution is safe to use and seems to be improving patients' subjective symptoms. So it'll be really interesting to see more studies with this solution and other solutions. Again, I said I was rapid firing through, so I'm going to go through a couple studies here in the next few minutes. But I really encourage you, most of these studies, again, this one's contact lens anterior eye, but pop into OVS too and see that. And Muriel, I'll just go through these, but of course these are Muriel studies. So if you want to hop on and say anything, you can certainly make comments. This one's just a quick one. This is a very interesting one, also looking at midday fogging. So this was the SCOPE study, and they had about 250 people respond asking about midday fogging, asking to report some of the different characteristics. So they looked at demographics, fitter experience, practice modality, and ultimately they compared diameters. They looked at number of removals per day. But ultimately, Muriel, correct me if I'm wrong, I don't think there was really anything that you guys found, no demographics. What was interesting to me was that no lens diameter was reported.
Yeah, lens diameter as well as haptic design. You know, we've heard
Oh yeah.
for a long time that if you more closely align the haptic to the anterior surface of the eye, you'll get less fogging. There didn't appear to be a relationship there.
Yeah. You know, so often that happens when we think something and then we test it. But yeah, I guess I didn't have that graph in here, but you're right. I remember sort of, you know, cocking my head a little bit at that one, that there was no haptic design. And even some of the impression based lenses showed midday fogging,
Right.
if I remember correctly.
That's correct.
Yeah. And so here they also didn't find a difference in the solution used to fill the bowl, but keep in mind that most of the patients were using saline. So so it's really not designed to look at that, but you know, nothing jumped out at us there either. All right, I think I've got another one of yours too, but I'll go through them so that you have time to talk about IOP.
That's fine.
So just quickly, this study here, again, looking at the solutions, this is done right up the hall from me at University of Houston and Dr. Marsak's lab. And they were basically, this was interesting. They just were looking, they're an optics lab. And so they are doing a lot of wavefront guided lenses. So they wanted to do a study to make sure that cleaning lenses with different solutions wasn't going to affect the optics of their lenses. And so they essentially simulated a year's worth of cleaning. They used unique pH and optimum, and thankfully found, these are some interesting graphs that you can view on your own time if you're so inclined, but the general result is there's no change in optical aberrations or base curves and specifically for those wavefront guided lenses. And so we can rest assured that we can tell our patients with those customized optics, they can still clean them as they customarily would, and don't have to worry about altering the optics. I'm just going to kind of skip through this one too, Dr. Schornack. Just basically looking at patient satisfaction. This was actually surveying patients, which was very interesting with keratoconus, and ultimately found that, hey, guess what? Patients are pretty well satisfied with scleral lenses. And I think you looked at some corneal GP wears, you can see here, and some scleral lens wears. So I'm not going to jump into this. Just for those of you who are interested in this, that's in the OBS. Same with this one here. I just wanted to shout out to another colleague, Daniel Fuller. He's the scleral lens secretary, and also looked at safety and efficacy of scleral lenses for keratoconus. Again, finding that they long-term safety and efficacy is established. So for those of us that are always wanting to cite something that says, yes, these are safe and effective lenses that patients can see out of, we're always looking for more publications that we can cite that important fact. So this is another one for those. And then two that are just dear to my heart, but I won't go into them because I want to give some time to IOP. But basically looking, this is Gonzalo. Yeah, I thought Gonzalo was part of this group, and his friends, and Afe looks like he was in this one too, and Root. So they looked at conjunctival goblet cells, didn't find any differences before or after lens wear, so that's good. And then this other study by another one of my colleagues, one of my classmates, Debbie Young, they looked at keratoconus subjects and actually showed that higher limbal clearance was subjectively showed more comfort in their cohort. So I think the conclusion there is limbal zone matters, and we'll see what more studies on that show. So with that, Dr. Schornack, I will turn it over to you.
Excellent.
To, chat about IOP.
All right. Well, IOP and scleral lens wear has been a topic of some conversation over the last couple of years. Just a real quick diagram here to describe what happens with aqueous humor production as well as drainage. Although I must say that this is grossly simplified. It turns out that there are so many things that can affect intraocular pressure. So everything from fluid intake, body orientation, you're going to get a different IOP if you're supine versus erect. Head orientation makes a difference. Eye position makes a difference. If you're looking in an extreme field of gaze, you're going to get higher than average IOP. If you've been exercising, that can change IOP. Your respiration heart rate can change IOP. We all know that there's some diurnal variation, and even manipulation of the globe or lids. For instance, the process of measuring intraocular pressure can cause a change in IOP. So all of this is pretty carefully regulated with a pretty advanced neural mechanism that will sense when there is a change in IOP and quickly take compensatory action in order to normalize IOP. But what happens when you put a scleral lens on the eye? There were some interesting studies way back before modern scleral lenses were even introduced. 1951 and 1953, Hooker noted elevation of IOP in patients who were wearing a glass scleral lens. Now, difficult to know whether that was due to corneal edema, because as you can imagine, a glass lens would induce quite a bit of edema, or if it was because intraocular pressure truly changed during IOP or during scleral lens wear. And he also reported that patients with glaucoma may be more susceptible to bigger changes in IOP than patients who did not have glaucoma. Although if we take a look at Miller's study from 1963, we could potentially hypothesize that increased corneal edema in patients with glaucoma could have been partially responsible for that greater increase in IOP during scleral lens wear. Interestingly, Miller also noted that it took some effort to remove a scleral lens from the surface of the eye, and estimated that the negative fluid or post-lens fluid reservoir pressure was 5 to 18 milligrams of mercury during scleral lens wear. So that's how much force, or how much sub-atmospheric pressure, if you will, there is during scleral lens wear. So In 2016, McMoney's wrote an article that hypothesized that scleral lens wear could cause an increase in intraocular pressure, because he observed that when you manually apply digital pressure to the eyeball, IOP goes up. And he also observed that when you put a suction cup on the temporal aspect of the sclera and then measure IOP on the cornea, you also get an increase in intraocular pressure. So he used those two observations to hypothesize that scleral lens wear could cause an increase in intraocular pressure by one of two mechanisms, or perhaps both. Scleral lens tightness could be associated with IOP elevation and in association with scleral and or corneal applanation and indentation. And that speaks to that post lens pressure, or the subatmospheric pressure that forms during lens wear. And then he also noted that there was a possibility that any scleral lens bearing zones located near the trabecular meshwork could have an influence on aqueous draining, and that should also be considered. So certainly any pressure on that episcleral vasculature could also potentially decrease efficiency of drainage of fluid. So there was a pretty immediate response to that particular paper. Our friend Stephen Vincent took a look at his ORA data on some of the studies that he had done with corneal swelling, and actually reported that IOP may decrease during short-term contact lens wear. Richard Pearson, who was a luminary in the early scleral lens world, also did a review of literature existing at the time of the publication of this article and concluded that there really wasn't enough evidence to give credence to the idea that scleral lens wear could or does not elevate intraocular pressure. So let's take a look at some of the studies. Now there's two ways to measure intraocular pressure change with contact or with scleral lens wear. Way number one would be to measure intraocular pressure immediately before you place a lens on the eye and then after you remove the lens. That can give you some idea of what's happening to intraocular pressure during lens wear, but we're really not measuring pressure during lens wear when we do that. So take that perhaps with a grain of salt. This was a nice study that was published in 2019 and showed that compared to a soft lens, intraocular pressure appeared to rise during scleral lens wear on the contralateral eye when measured with eye care. And let's move on to the next slide. Dr. Sherry Now and I performed a study here at Mayo using the pneumo tonometer. That is an instrument which has been studied with both central and peripheral IOP. We enrolled 29 patients, 29 plus or minus 6 years of age, so relatively young and healthy. We found no difference between central pressure in the study eye versus the control eye prior to lens wear, and the peripheral IOP measurement was also somewhat more variable, but very similar between control and study eye. After 2 hours of lens wear, the peripheral IOP on average did not elevate, but you'll notice that there are a couple of patients in whom intraocular pressure did go up pretty markedly. So although average pressure didn't go up, there was some elevation in IOP. Hard to say whether that was measurement error or tight fitting lens. We did use diagnostic lenses for this study. So questions remain. And then immediately after lens removal, central IOP was still mildly elevated, but again, mean IOP did not change using pneumotonometry. The next study took a look at intraocular pressure using a diatom, the transpalpebral tonometer, and discovered or reported that there was a statistically significant increase in intraocular pressure during scleral lens wear as measured with the diatom compared to baseline. Now let's get into some 2020 studies. who remembers Schiatt's tonometry? I haven't used a Schiatt's tonometer since I was in school, but they still exist and they have been validated for use on the sclera. So this was kind of an elegant study that used Schiatt's. Patient was lying down when IOP was measured, but they found no change in intraocular pressure during scleral lens wear using that Schiatt's tonometer on the sclera. Now, Maria also took a look at IOP and optic nerve head morphology during scleral lens wear, and she was a bit of an overachiever here. She measured intraocular pressure prior to lens application and after lens removal using eye care, and also measured intraocular pressure using the diaton during scleral lens wear. And Maria, if you want to jump in and tell us a little bit about that, you're welcome to do so.
Oh, sure. Just quickly. So yeah, we wanted to look. So part of what we were doing was really looking at the diaton to see if we thought it was a useful instrument to use. So if you look at the test and the control eyes here, with the diaton didn't really change. Certainly not significantly. With the eye care, similar to some of the other studies, you know, you get a couple that it increases enough on, so it pulls that average, but it definitely ends up being significantly increased with eye care. We also, by the way, found that the eye care and the diaton don't really match up very well. So that's a discussion for later, but I'm not, anyone who knows me well knows I'm not a huge fan of the diaton, but there's people that use it.
Excellent. Well, the scope group also took a look at diaton and wanted to know why we were getting such different results between pneumotonometry and diaton. So we actually did a study where we performed diaton and pneumotonometry on the same eyes within seconds of each other. We found no change in intraocular pressure during an hour of scleral lens wear with either large or small diameter lenses with pneumotonometry. But if you take a look at the diaton row, IOP went up pretty dramatically immediately after lens application and came back down almost as dramatically immediately after lens removal. So we suspect that there is a difference in the measuring tools. And in fact, when we ran statistical analysis, we discovered that it wasn't lens size, it wasn't timing, it was simply a difference in instrumentation. That's what popped out as the real difference between those two. So there is disagreement between diaton and pneumotonometry or Schiatt's and other measurements. Which one's right? We don't know yet. But let's move on and talk about something that might be even a little bit, oh, never mind, got to talk about Stephen first. Stephen's paper took a look at eye care tonometry measured during intraocular or during scleral lens wear with a fenestrated lens. Now, obviously, patients aren't going to be able to wear this, but he did discover that IOP went up by about 3.6 millimeters of mercury immediately after lens application and then came back down nearly to baseline, or basically to baseline after lens removal. So there may be something going on with scleral lens wear due to the haptic compression. But does an isolated IOP measurement really mean very much? You know, when we're taking a look at glaucoma, we take a look at other things as well. We take a look at optic nerve appearance, we look at OCT of the optic nerve, we take a look at visual field. So there are a couple of studies that were published this year that are starting to look at some of these other parameters. Langis Michaud published a paper on Brooks membrane opening minimum rim width changes in the optic nerve during scleral lens wear and compared those to normal diurnal change on a separate day and discovered that when a patient was wearing a scleral lens, the minimum rim width changed more, which would suggest an elevated intraocular pressure during lens wear. And Maria also studied this particular phenomenon. Maria, feel free to jump in here if you'd like, once again.
Yeah, you know, I'll let you just kind of keep going. And if people have questions about it, I think the key is just stay tuned on the optic nerve and make sure checking, if it's a glaucoma patient, they should be getting OCTs and all that optic nerve stuff anyways. So I don't hesitate at this point to get that data to follow the nerve rather than to try to indirectly follow the pressure in patients.
Excellent. So this is all very interesting, but what actually happens to patients? Maria mentioned that I am primarily a clinician. These two studies are from earlier, the first two studies here, and they took a look at corneal biomechanical properties, found no change in corneal hysteresis or cornea-corrected IOP after 1 year of scleral lens wear in patients who had had refractive surgery. And they also found that there was really no change in these parameters in patients who wore scleral lenses for keratoconus. So that's encouraging, certainly. It doesn't appear that there's any long-term negative effects. More recent studies, again, Gloria Chu's group found really no change in intraocular pressure after, oh goodness, I forgot the number of years, but this is another study by Elisa Kramer and Stephen Vincent. Didn't really find a change in intraocular pressure over time, although they had a relatively high dropout rate. Just one more thing, patients with glaucoma do wear scleral lenses. And so there have been a couple of studies that have taken a look at the modifications that are necessary if you're going to put a scleral lens on a patient with glaucoma. So moving forward, what do we need to look at with regards to scleral lenses and intraocular pressure? Well, number one, patient population. Most of the studies that have been done so far are on young, healthy patients, and that might not be the same. They might not have the same reaction as a patient with glaucoma or issues with neuroregulation of aqueous dynamics. We need to pay attention to the devices used, the timing used, and then we should keep in mind the clinical relevance of an isolated IOP measurement. As Maria mentioned, if you've got a patient who is a suspect for glaucoma, you're going to want to measure other parameters as well as IOP. So I think with that, we had a whirlwind tour of IOP.
Yes, that was so great. I loved it. We do have a couple of questions and we have a couple of minutes. So the first question is from our friend Karen C, who I assume is Carrasquillo. So she says hello, and she's wondering, kind of a question to you and I, but also to Steve too, that why there's still this push to state that we should be worried about scleral lenses in IOP, even when these studies really show no significant changes and perhaps the instrumentation is an issue, and sort of saying when clinical data don't necessarily support that there's an acute change. I'll answer quickly first. I'm always, looking for a problem before. I think that's probably all of us. Like, let's find it before all of a sudden we've got, people who might have been getting damage from their nerves from this. And for me, the research shows, I see that it still does appear to change IOP in some patients. And I think that's really what we need to figure out is who is going to be at risk for this truly, and is there a lens design that caused it? But I certainly don't have a doomsday attitude. I was thinking about this the other day as I was looking at this lecture. I've never once taken a patient out of scleral lenses because I thought it was worsening their glaucoma. I have, however, had, a small amount, but enough where their pressure will be increased right when the lens comes off. And it takes a while to go down. And so I think we just have to figure out where that risk really is. And anyways, what do you guys think?
Oh, I completely agree. I have never taken a patient out of a scleral lens out of a concern for intraocular pressure. And, frankly, I've never hesitated to put a patient with glaucoma into a scleral lens. Just because in general, the risks are going to outweigh the benefits there. I think when we're talking about IOP, we need to recognize that the forces that control IOP are so much more complex than we are realizing. Simply the process of putting a lens on and taking it off can change IOP. So if we're going to study this in detail, and we're welcome to do so, but man, there's just a lot of things you got to control in order to come up with meaningful data here. I think in healthy patients with an intact regulatory system, this is not a matter of concern at all. The only concerns that I would have would be patients who might not have the regulatory or the aqueous humor regulation system that is intact and healthy. So I don't lose sleep over it.
Steve, anything to add?
No, I mean, I agree with Muriel. I think based on the published research, certainly in healthy eyes, there's nothing drastic to worry about, and patients with glaucoma and tubes and trabs should be watched very carefully.
You're going to watch them carefully anyway.
Yeah.
Right. Muriel, another question for you here. What is the latest, if any, I'll add, research studies on safety of wearing sclerals for scuba diving? And yeah, and you know, are we sure? Do we know anything about this?
I have not seen a single study taking a look at scleral lens wear in other than atmospheric pressure.
Same.
So yeah, if any of you are researchers out there, there are mechanisms that will allow you to change atmospheric pressure around the eye. I'm a clinician. I do not have access to that, so I won't be doing that. But Maria, perhaps that could be your next life.
Yeah, we'll see. Add it to the list. When I start getting graduate students coming to me instead of
being the graduate student.
So Steve, you're in Australia. I mean, that's where you guys are the ones who scuba dive, yeah?
We're all in lockdown. There's no scuba diving right now.
Yeah, there's never been any scuba diving in the middle of Minnesota.
Okay, a couple other questions. I think these ones are for me. Any less inflammatory markers of using one of the newer scleral lens salines? No, but we're working on some stuff with that, so stay tuned. Is there any difference with inflammatory response with filling up with saline versus artificial tears? Again, same response there. We're working on that. I know a couple other groups are working on that too, but good questions, really good questions.